In this study, we tested the effects of chlordiazepoxide, or CDP, on anxiety and activity levels in younger versus older rats. This is an overview of our research project, but each section will be covered on the next few slides. By nature, rats are animals of prey, so they demonstrate thematic behavior, which is a tendency to remain bordered by walls, if they have that opportunity. Open spaces tend to be anxiety-inducing to rats, and common ways to measure this include the elevated plus maze, or EPM, as well as the open field. Benzodiazepines are commonly prescribed anti-anxiety medication, and they've also been shown to have different effects in rats, as Griebel and colleagues showed that they might have sedative-like effects, while Desjardins showed they increase activity levels. We want to know if age is the variable behind the inconsistent effect of benzodiazepines. So we predicted CDP will reduce anxiety more substantially in younger rats and will increase activity levels in younger rats, but not older rats.
The subjects of this study consisted of 39 female long Evans rats. The rats were grouped by age: young naive rats, older naive rats, and older breeder rats. The rats were housed 2 per cage and were moved in together 4 weeks before the start of the experiment. Rats were housed in a standard plastic cage with a 12-hour on-off light cycle. Researchers used a computer software, AnyMaze, to record the rats during each task. Injections occurred 30 to 50 minutes prior to each maze. Researchers injected half of the rats with chlordiazepoxide, CDP, with a dose of 7.5 milligrams per kilogram. Saline was used as the controlled substance. The drug was labeled with either an X or O. There was a 30 to 50 minute wait between injections and the start of the task. The first task during the first week is the elevated plus maze. This maze lasted 5 minutes long. The second task in the second week was the open field maze. This task lasted 10 minutes.
The results from our anxiety measures on the EPM showed the CDP group was found to spend more time in the open arms than the saline group in all age and experience groups. No significant difference between younger and older rats was observed. On the open field, CDP did not increase time spent in the middle of the open field in any age groups. You can see the graph for the EPM below. The results from our activity measures on the EPM and the open field both revealed that CDP led to an increase in activity levels in younger rats, but not the older rat groups. These were measured by the mean distance traveled on either the EPM or the open field. So both tasks yielded the same results, which means CDP had a significant effect on younger rats, but not older rats.
For the discussion part of our poster, we want to reiterate that all groups administered the chlordiazepoxide spent more time in the open arms of the elevated plus maze, but there was no significant difference between younger and older rats groups in anxiety. However, younger rats showed more activity overall in the elevated plus maze. Because of this, we thought it supported that CDP interacts differently in younger and older rats when comparing activity, and that corresponds to previous work done by Reeves and Schweizer in 1983, which suggests that there are differences in the actual receptors between younger and older rats in the brain, which is why drug works differently between them. In the future, we want to increase the amount of participants we used, or maybe change our anxiety measures for something a little more accurate to pick up different changes in behavior in the open field. And we thought this all is important because humans also may show similar changes in receptiveness of anti-anxiety medications with age, and how these changes occur would be important in the future.